Hey everyone, hope you're doing well and had a great Thanksgiving this year. I'm back with another GMAT exercise brought to me by one of my students, so let's just jump right in. So this one comes straight out of the 2018 official guide. It was sent to me by one of my GMAT students, and it's a bit of an oddball question. Take a quick look before you start trying to solve it. Basically what we have is a data sufficiency exercise, and the multiplication table has been presented to us with 3 columns and 3 rows. Labels in each column and row is ABC. All 3 columns are labeled ABC, and all 3 rows are also labeled ABC. So essentially, when we look at, let's say, first column, first row, the table suggests that A times A equals D. And then we can look at other rows and column combinations and see, for example, that A times B equals E, A times C equals F, and so on and so forth. So obviously we have no numbers here, just a whole bunch of variables. And the question is, what is the value of C? All right, so let's give this a shot. I've already rewritten the graphic on my scrap paper over here, and also wrote down the question. It's always important to remind yourself what you're being asked. In this case, it's what is the value of C? So sometimes what I like to do when I have an abstract question is just try some simple numbers and see what the result looks like. So if we go ahead and do that with 1, 2, 3 rather than ABC, we can see the results look something like this. Right? And I don't know, if we try it again, there was no restrictive suggesting that the variables have to be positive or negative or 0 for that matter. So we can also try, for example, I don't know, 0, 2, 4, and recognize that the result in this case looks like this. Right? So this just gives us some context. We see that, in every case we get obviously different answers, and then maybe we might have noticed by trying these basic numbers that when one of the values is 0, we get a zeroed out column and row, and when one of the values is 1 of the rows and columns is basically a repeat of the original numbers. You may pick that up from trying at least these 2 triplets that I've tried here. Okay, so let's test data statement 1, which suggests that C equals F. So you might look here at our matrix and see, okay, so C equals F, and ask ourselves what situation would actually give us that result. And with a little bit of thinking and maybe looking back at our trial matrices here, well, here C equaled F, and we multiplied the C, in this case it was 3, by 1. And that might spark you realizing that any number multiplied by 1 will give you the number back in return. So let's test data statement 1, recognizing that we're going to hold A to the value of 1. And what we're looking to do here is to see if we can unequivocally have an answer for C, holding to the data statement rule that C must equal F. Well, let's try. Well, obviously here we had C equals 3, and we had 1, 2, 3 and 1, 2, 3, and the result was C equaled 3. What if we just simply go with 1, 2, 4, 1, 2, 4? That would give us 1, 2, 4, 2, 4, 8, 4, 8, 16 as our matrix. Well, we see we've held to the rule that C equals F. In this case it's 4, but in this case it's 3. So since we've come up with 2 scenarios, keeping the data statement valid, but getting 2 different values for C, data statement 1 alone is not sufficient. A data statement 2 simply says that H can equal 0. Hopefully we can see, as we've tried a few of these matrix combinations, that basically with H being with h being equal to anything other than 0, you should recognize that you can come up with any number of values of c here. So clearly, data statement 2 is not sufficient to answer the question. So let's finally look at c and whether or not the statements together are helpful. Well, if we stick with the matrices that we've already drawn here, we recognize that we've actually varied h, and h doesn't equal 0. So in fact, we've already proven that c is also not possible, because with h in this case equal to 8, in this case equal to 6, we varied h, they in both cases didn't equal 0, and we still couldn't prove one value for c. And therefore the answer to this exercise is E, not solvable. So again, the answer is E to this data sufficiency GMAT question. And if you have any questions or comments, please do leave them below this video on YouTube, and make sure to follow me there or hit me up on Facebook at No Brainer Test Prep.